Hello everyone, Joe here. I'll be going over today in this video how to factor quadratic terms with using algebraic tiles. This concept can be a little bit tricky at first, and I found that some students, they get caught off by guard. Usually in the textbook or the explanations in class, they start off with algebraic tiles and the student is like confused, okay, what is this shape supposed to stand for or mean, and what is the other shape, like different shapes are involved here. So it gets a little bit confusing. It's different than the rubric that we follow for product and sum rule in factoring quadratics. So we'll go over the basics with you. We'll start off with the two factors that'll be given to us, and then we can work our way afterwards backwards to find the factors themselves using algebraic tiles. So I'll be going over the steps with you today, and all I need for you is get your Alaskan fish oil, and then if you want, a cup of Java Joe, and which I have here, and smells good, tastes good, I guess. That's great. And so let's get right to it. All right, so let's start off with talking about the algebraic tiles themselves. So when we look at a term, we have to look at a variable as something, or as an object of some sort. Let's say, for example, if we see a lot of x and y's in our regular textbooks and at school. So what does these x and y's actually mean? Well, they can mean practically anything. You hear that a lot by teachers, but they really don't go into too much detail. Okay, what could that anything be? Well, we can look at x as being x amount of cups, or y as y amount of oranges. We can assign a meaning to those variables. So if we're looking at a trinomial, let's look at an example. Let's say we have x squared plus 2x, and then plus, we can look here, 8. Just to give you an example here. Well, in this trinomial, the 8 represents the number 8. So it could be, in general, like the number 8. It doesn't have anything attached or associated with it. It doesn't have a variable associated with it. It's a constant term. So we could be starting off with the constant. When we have 0 oranges, we just have 8 counts, for example. But we're looking at 8. That's a constant term. If we look at 2x, we have x as a variable. We can look at x as something. We can say oranges or cups or pencils or pens or anything of that nature. And then we have x squared, and we know that to get a product, to actually get an x squared, you'd have to basically multiply. For example, when we're looking at 5 times 5, we know 5 times 5 is 25. But actually, we can rewrite that 5 times 5 as 5 squared. So any term multiplied by itself, it can be written as the term itself to the power of 2, or squared. So if we look at x squared, that's basically x times x. Okay. Now, when we're looking at algebraic tiles, we have to assign a shape to every single term that we got here. All right. So let's say, for example, we have 8 as a constant. We're going to assign each number, we're going to assign it like a square. So let me just clear the whiteboard here, and we'll go over that concept. So we're going to assign the number 8 a square. Okay? Now, we know 8, the number, is different than x, the variable. So we're going to have to assign x a different sort of shape, or to make it simpler, we call it a tile. Each individual unit like this for the 8, we're going to assume that each individual unit means 1. So if we have 8, that means we have 8 constants. So you would end up having 8 of these little squares. Actually, I'll make things a little bit simpler here. So I'll just grab one there. I'll just put this here. And then let me just copy all of this here. Okay. So these 8 little blocks, we're going to call them, they're supposed to be squares. Sorry, I'm not really the best artist at this point using the computer. But we have 8 blocks representing each constant, like each term, each number, representing 1 block. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 blocks. So now if we look at x, we have 2x. So if we have 2x, we have to represent x with a shape. And to make it simpler, or to make it easier to work with, we're going to assign x a rectangle. So the x rectangle is going to look something like this. So we're going to call this x. And let me just assign towards each. I'll just change this here. So this is going to be 1, 1, 1, 1, 1, 1, 1, and 1. And each rectangle is going to be representing x. So I'm going to make another x. And here we go. So this now represents our second term, which is 2x. We have x and x. Again, the tile isn't like something concrete. You could have different shapes, but we work it this way so it makes more sense to put the algebraic tiles together. And in order for you to sort of build on finding the factors that give you or generate the algebraic terms for factoring this quadratic. So if we look at x times x, okay, so I'm going to bring it a little bit closer to the side because I want to have space to draw my next term, which is going to be my x squared. So I'll just move this here. And then we're going to take this and we're going to have to rotate 90. So now my x squared is going to be actually x times x. So if I take x horizontal and x vertical, when I multiply them, just like the area of a rectangle is length times width, if I take x times x, that whole shape now can be filled in to represent x squared. So let's take a vertical block, or vertical here. I know it's a little bit constrained. And now we're going to have this sort of square representing our x squared term. So x times x is x squared. So then let me just get this going here. So my shape now here would be x squared. So just to make things simpler, I'm going to erase the outer rectangles, or maybe let's just change their color. I'll just keep this like that. So that's done. And let's get my brush. This is going to be our x squared. Alright, so that's x squared. And then on the outside, we'll just change it to like an orange color. We'll just make it like squiggly here, just to represent that this x squared was generated from the 2 blocks x times x. Okay, so now we've created the different terms of this quadratic, simple trinomial, in shapes. Okay, now the goal here is to rearrange these shapes in a way to find the 2 factors that would be involved, okay, on the outer term. So if we went to like classical sort of product sum rule, you would have to do basically what two numbers multiply to give you the outer term, 1. So your coefficient here, if there's nothing there in front of the x squared, we have a 1 there. So 1 times 8, you need to find two terms that multiply to give you 8. Okay? And they add up to give you 2. So that would be your product. And the sum would have to be 2. Well, the issue here is that okay, so product is 8. 4 times 2. 4 and 2. Okay guys, so now that we have an idea of how to take the terms in an equation and generate them in a way to look as a shape or an algebraic tile, we're going to go and work with a different example with now factors given to us. We're going to write the factors as algebraic tiles on the outside, and then we're going to generate all the terms that are basically these two factors when they multiply as we do our product rule, or sort of as we multiply and do distributive property, we would generate okay guys, so now that we see how we can take these terms in a quadratic relation or quadratic function and take each term and represent it as an algebraic tile, we're going to go to an example where we have two factors being multiplied with each other, represent these factors as algebraic tiles in shapes, and then generate the simplified expression when we applied like distributive property on both those factors. So let's go over that. I'll just erase this board quickly and we'll get going to that question. So I'll just erase this. Okay. So let's start with two factors being multiplied with each other. Let's start with x plus 3 times x plus 2. Now, in classical sort of, as a rubric that you learn in class, you can apply the distributive property. Let's write out the terms. So in distributive property, you start with x times x, and we know x times x is x squared. And then again, the first term x multiplies with 2 to give you plus 2x. 3 times x gives you plus 3x. And then 3 times 2 is plus 6. If we continue with this, what we end up getting is x squared plus 2x plus 3x is basically 5x, because again, they're the same term, they're under the same power, so they're the same sort of concept or idea or object, if you want to think of it as an object. So 2x plus 3x is 5x, and then plus 6. Okay, so we know as we expand and we enter a simplified expression, x squared plus 5x plus 6, that's a simplified expression for the factored form, x plus 3 times x plus 2. Now, how can we generate this using algebraic tiles? So we're going to do this very quickly, sort of similar to what we just did in the previous step in the explanation. So we're going to draw on one column is going to be our expression x plus 3. And on the other column is going to be so we have a column, and then we're going to have a row, and in that row it's going to be the x plus 2 term, or factor, sorry. So let's start off with, this is going to be our x, and so that column represents our x. We're going to have 3 individual blocks. Okay, and then on our top row, let me just move this aside a little bit here. Okay guys, so now we're gonna show this using algebraic tiles. So using algebraic tiles, we're gonna represent one column as our factor x plus 3, and the other row above it is gonna be x plus 2. So let's start with x plus 3. X plus 3 is represented by a rectangle, and so that's representing our x term. And then our 3 is going to be 3 separate blocks. So that's going to be 1 block. And then, let me just match this up properly. And we need 3 of those. So let me just paste. 2. And then 3. I have to move this up a little bit here. So that's our third block. And again, that's our x plus 3 column. Now we're going to represent our x plus 2 row at the top there. I'm just going to just quickly remove these arrows just so that we can work through this and create some space. And let's get going ahead now. And let's take this, copy, paste, and I need to rotate this. Okay, there we go. So this is now our x, and then we need 2. And this is 2. So we got this going. Now the next step what we're going to do is we're going to be multiplying these blocks as if they were variables. So let me just rewrite this here. This is x, that's x. That's 1, 1. Each block represents 1 unit, and that has 3. So the first x times x, that's going to give us the area of a square. So x times x gives us x squared. So let's just put that here. And what I'm going to do now is I'm going to write here x squared. Okay? The next thing that's going to happen is I'm going to multiply my x block with each individual term. each individual 1 block. So x times 1 gives us x. So let's just work through this. And so now this is going to give us an x. And another x times 1 gives you another x. So this would be again x. And we'll write that inside here. That's going to be x, and that's going to be x as well. The same thing applies here. You have x times 1, and we know x times 1 is just x. Same thing applies. You have, again, x times 1, and that's, again, x. And the same thing happens, x times 1 will give you another x. So there we go. We're going to write those inside here, inside of the blocks that we have, x, x, x. And then finally you have the individual ones multiplying with each other. So that would give you 1 times 1 is 1. And again, 1 times 1 is 1. Actually, that's the wrong shape. Sorry. I don't want to get you confused here. Just let's just look at my. Yeah, there we go. So show copy. All right. So that's looking good. And again, 1 times 1 is 1. You're going to keep on doing this. It's not that complicated at this point. Like, you can probably see the pattern, what's going on. And again, my apologies, it isn't perfect in terms of the shapes, but I'm trying to work my way on, giving you a very accurate sort of representation here. But everything else is correct. This is going to be 1, 1, 1, 1, 1, 1. You're going to put an equal sign, and all we're going to do is just add up whatever we've formed on the inside of the multiplication of these tiles. So things in yellow, you're not going to write out. Things in white, the white variables written in white here, you're just going to add up those terms. So let's say we have x squared, we only have one x squared, so you're just going to write out x squared. How many do we have of the x's? So we have 1, 2, 3, 4, 5. So we're going to write out 5x plus 5x. And then we're going to have the ones, which is your variable. So we have 1, 2, 3, 4, 5, 6. So you have 6 of those, and that would give you then 6 only. There's no variable attached to it, 6 units. So that would be plus 6. And there we have it. We've just factored pretty much using algebraic tiles. And this is sort of the easier part in a way, because you just have to write out your, this is not really the factoring, so my apologies. This is more multiplication of factors to generate the simplified expression. We're going to be going over an example now, working backwards. So let's see ourselves working backwards, and we're going to be given our simplified expression and now generate the factors using algebraic tiles. And that's pretty much what you need to cover in class. That's what they cover the most, is like both ways, when you have the two factors and then you generate the algebraic tiles, and when you have afterwards a simplified expression, quadratic, and you work your way backwards to find the factors. Okay guys, I'm back again, and that was a quick break. We're going to go back to simplifying, or actually starting with the simplified quadratic expression, and then we're going to work our way backwards to find the factors. So let's start with an example. X squared plus 10x plus 25. So in conventional sort of the rubric that you learn in school, you can use the product sum rule, and the product sum rule states you need to find two numbers that multiply to give you, basically there's a 1 here, 1 times 25, 25, and they have to add up to give you 10. So I know this may be, afterwards you'll notice that it is an easier question or easier problem to work with, but let's work with this question first, and we'll go over a more challenging one afterwards. Okay, so we have x squared plus 10x plus 25. What I'm going to do is I'm going to draw out my algebraic tiles, respectively. Then I'm going to rearrange them in a way that how I rearrange them would generate the proper factors to work with. So I know this may be a little bit harder to assemble, but we'll go over it as well together. So let me just rewrite this here. Okay, this is, so we said it's x squared plus 10x plus 25. And so we have x squared as one sort of factor. I'm going to draw this out. Usually it's the first one there, x squared. Then there's 10x, and then there's 25. So let me just draw out, that's x squared, and then I'm going to draw out one of these as x. Let me just get that here. So we're going to call this x. I'm going to have to copy 10 of those. That's another. 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 Okay. Another. Okay. So we have here, I just align them like this. So we have x squared, x, 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 and x. Lots of x's here. And again, we need, that's just 5. We need 10. So again, we're going to arrange this same shape. And so that's 1. Actually, let me extend it a little bit here. Okay, like that. 2. 3, 4. Okay, so I may need a little bit more space. So, let me just generate a little bit more space here because it's getting a little bit crowded. There we go. Okay. That's another one. Okay. Okay. Okay, so we need one more x, and now we have 5x. So we'll write that in again. And you may ask, so okay, you may ask this question that, okay, why did you assign 5 to the right and 5 as a column? Well, I did that because if I assigned all 10 of them to the right, then if I look at the multiplication that's going to happen on the outside, I would only have basically one x term, and I wouldn't be able to generate the ones. The reason being, if I had all 10 terms on one side and I put all 25 to the bottom, like 25 ones, then if you do the multiplication, it would not work out. You would end up, we can show how that doesn't work in a second, but let's just continue with this. And what's going to happen now here, I'm going to put my 25 ones. How do you know it's going to give me 25 in this whole area? Well, if you notice that each of these represent 1x, x, x, and this is the simplified expression. Therefore, if we had on the outside ones, then you would end up generating the 25 units on the inside. So let's just take a look. Okay, I'm going to put lines here. So that's one line, another line, another line, and another line, another one here, another one here, here, and here. And these are all going to be my ones. So I'm just going to have to shuffle, just bring this a little bit to the right. Okay. And then I may need to move this up just a little bit here. That's a little bit too high. Okay, so now let's get to the outer portions. I'll just change the color. So if this here now represents our x term, okay, I'm going to have to take this and move that here. So if this here represents our x term, so that column, and then we're going to also have one on the top here representing our x term, then you would have to have x times x giving us x squared. So this would have to be x, and this would have to be x. So it's sort of working your way backwards. In order to get x squared, you have to have x times x. Now let's come to here. If this block is already, we assigned it x, and what you have here adjacent to the x squared block, you have an x block. Well, x, you have to say to yourself, okay, x times what gives me x? Well, x times 1, right? So x times 1 gives me x. So therefore, this top block has to be 1 here. So you're going to have a 1 there. And the same thing, x, same thing here. So x times what gives me, so you put a question mark to yourself, okay, x times what gives me x? Well, it has to be 1. Same thing here, x times what gives me, yeah, put a question mark, x times what gives me x? 1, and etc. So you have to do it that way. And let's take a look. So that has to be 1. 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 Okay? So now we have all the factors from my top row. X plus what? x plus 1, 2, 3, 4, 5, x plus 5. So I'm just going to draw this out here. So that's 1, 2, 3, 4, 5. And the factor that this is made up of is basically x plus 5. Okay? Let's continue further. Now, here, again, you're going to ask the same questions. You have x as your block. So if there's nothing here and what you got up here is x, well, you have to ask yourself, x times what? So you put a question mark. So x times what gives me x? Well, we just talked about that. X times 1 gives you x. So then what you're going to have to end up having here again are 1 blocks. So 1, 2, and then 3, and then 4, and then 5. And that then generates your 5 blocks. I know I'm just constrained on the space a little bit here. So everything else is just 1s. 1, 1, 1, 1, 1. And then last but not least is your numbers, your constants. So again, you're going to ask yourself, well, in this case, you don't have to work backwards anymore. You have the terms set up. You're going to go to your 1s. 1 times 1 gives me 1. And then 1 times 1 gives me 1. And then 1 gives me 1. So all these are 1s. So basically, what's happening here, we're using algebraic tiles. If you can generate the proper sequence, you don't have to do much of the multiplication. You just have to work your way backwards. So we have x plus 5. And then again, we have another x plus 5 as another factor. And these are all just 1s here. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, all of that. Those are all 1s. Pretty repetitive, very boring. As you know, math can be very boring at times, but it's used for many beneficial applications in life. And I use it on a daily basis because I mainly tutor, I teach. But at the same time, math can be used for many applications in your daily life even. For example, when you want to do a simple calculation as to how long you want to empty your swimming pool. If you know the rate of how much the pump that you have pumps out water and you have approximate rate, you can determine then the time it takes to empty that pool and how much time you need to allocate for, maybe being present if you need to be at home when that's happening. Another thing, I know that I'm maybe going off a little off topic, but math is very important. It is dull many times, but when you start trying to use it to solve problems in everyday life, it's so much more rewarding and enjoyable. You really enjoy math. You feel a connection. You feel intelligent. You feel the room fills up with intelligence once you get to work through math problems. It's such a good feeling. Okay, so now we have the two factors, x plus 5 plus x plus 5. And we're going to take a tiny little break. And next we're going to go over maybe a little bit more difficult kind of question, something dealing with a complex quadratic equation and how to use algebraic tiles using complex quadratics. Okay, stay tuned. I'll just bring this expression here to the right. Maybe I brought that a little bit too much. So yeah, that works. And again, we're going to be working with algebraic tiles. So as we mentioned earlier, each term is represented by a shape. The x squared is going to be represented by a square. The x terms are going to be, the 5x is going to be represented by rectangles or rectangular bars, 5 of those. And then each constant, in this case -3, it's going to represent 1 unit of some sort. So in this case, we have a -3. But let's represent our x squared first. Let's start with that. So the inner terms are going to be white, and our factors are going to be in yellow. So we're starting off with x squared. So what I'm going to do is I'm going to draw out two sort of squares. And then this would have to be here. Just like that. So that's my x squared. I'm going to write that out here as x squared. As x squared. So going back from the previous segment, if we have x squared, we know that's going to be generated by 1x times 1x. So on flanked on both sides, on the column and on the row, it has to be an x bar. So we're going to put that in yellow. And so we're going to have an x bar here. And no, that's not what I want. Okay. Another x bar here. And flanked on the top is going to be another x bar. So all these are representing x. So this is x, this is x, and this is x. And that matches up with the data that we have. We have 2x squared, x times x gives you x squared, x times x gives you x squared. That's x squared plus x squared gives us 2x squared. So that's covered. The next, what we're going to be dealing with is 5x. So if we're going to be sort of following a symmetrical order here, we can't get 5 bars to give us 5 in a row in a symmetrical manner. So we're trying to form a box here, a filled up box. We don't want any gaps in the box. So if we drew 3 across, 3x bars, and 3 on the bottom, 3x bars, that's going to give us 6x. So there's something wrong here. We can't have 6x because our expression is 5x. So let's first draw out the 6x and see what we can do afterwards to work around and generate or give us 5x. So let's take a look at that. So the first thing we're going to be doing is we're going to draw our x bars. It's 1, 2, 3, okay. And then another 1, 2, and 3. Okay. Now typically here we know that we need 5x, but what I'm going to do for now, I'm going to write out the 6 x's here for now. And you have to say to yourself, well, to get to 5x, I need to take 6x. If I have 6x, how can I get to 5x? Well, you'd have to subtract 1x. So if you have 6x minus 1x, that gives you 5x. So what we're going to do here, instead of writing x for the last block, what we're going to do is we're going to write minus x, and we're going to change the color. So I'll change the color to red, and we're going to put this as minus x. So I'll just draw this out again, like as a red shape. So that's going to be minus x. That block here is now representing minus x. And go back to our brush. So here, this is representing minus x. So 6x, again, minus x gives us 5x. We filled in all the gaps. That minus x represents something. It represents a subtraction term, even though it's sort of like void in a way. But in this context, It is a filler because we do have negative terms, we do have 0, and we do have positive terms. So we're going to represent something as a negative x. So then if we look at the multiplication pattern that needs to happen, you're going to say to yourself again, x times what? You're going to put a question mark, just say that. X times what gives me x? Well, you know that x times 1 gives you x. So we're going to take another block here, and we're going to represent this by 1. That represents 1. That represents 1. That represents 1. Okay. Now, if we follow the pattern to see if that works, let's take a look. X times 1, so I forgot, I have to write this as a 1 here. So let me just take away this. This is going to be 1, 1, 1. All right, let's go back. So if x times 1 gives me x, x times 1 gives me x, and x times 1 gives me x. So all of those give us our x's. That's fine. So that's great. So that's fine and dandy. This whole set is ready. And in the meantime, our first our row factor is there. We have x, 1, 2, 3. So it's x plus 3. Right? So I'm going to write this factor out on my set here, underneath the set. So this is going to be equal to x plus 3. So we got our first factor. Now we need to find the second factor. Well, let's go ahead. So here we have 2x, okay, already. And that's all the gaps are filled. So there is no more space. But we know that to generate our expression, we need 2x squared plus 5x minus 3. Okay? So what's going to happen is this negative term needs to come from somewhere. Okay? So let's take a look and let's follow up here. So we have x times x, that's giving us x squared. That's done. X times 1, that's giving us x. X times 1 is giving us x. And x times 1 is giving us x. Well, all right. So okay, so continuing on, we need 5x. Well, to fill in the gaps, if we have 2x on the right column, on the left column, and we have x plus 3 on the top right column, which matches up for our first set. So our first set here is x squared plus 3x, that's fine. If we continue, we're going to end up getting 2x squared plus 6x. So this is already filled out, but there's some stuff that's missing. First of all, 2x squared is right, that's done. Second thing that we need to look out for in here is what's missing is that we have 6x. So x plus when you multiply by 6 is giving us 6x, but in our expression we have 5x. So knowing that, there has to be another sort of term there that gives you a 5x. The third thing that's need to look out for here is there's a negative 3 term in the quadratic expression here, quadratic relation, and that negative 3 is not visualized in our algebraic tiles. So technically we need a term that's not adding 3 but subtracting 3. So we have to keep that in mind. So the first thing that we need to look at is 5x. How can we get from 6x to 5x? So you have to say to yourself, what can I do with 6x to get to 5x? Well, I could, I can't multiply, I can't divide, I can subtract 1. So if I can subtract 1x and find something that represents, subtraction, then we can generate our 5x term. So what we can try to visualize is we need to have a minus x. To get a minus x, we can think of this as plus x. Okay, I'm going to change the color. And instead of having it as a plus x block, we're going to represent it as minus x block. So as a minus x block, that represents something. It's filling the space, and it's still part of sort of a tangible integer or value, something that's in the negative region, something it still could be there. It's a negative entity. So if we're looking at negative x, this matches up and follows what we need here. So we're going to end up with 6x minus x. That gives us 5x. So that works fine. That's great. So everything here works perfectly. So that negative x block, we're going to put that there. Okay? And to really generate that negative x, you have to ask yourself, we have x, and here we don't have anything. We don't know what it is. So you have to ask yourself, what times x? You put a question mark and you ask yourself, what times x gives me negative x? Well, we can't be 1. 1 times x gives us x. How about negative 1 times x? If we have negative 1 times x, that will give us negative x, and that fills in the block that we need. So negative 1 times x would work. So that block there is going to be our negative x block. Sorry, a negative 1 block. My apologies. So that's going to be a negative 1 block, and we're going to change the color because that has to be representing negative 1. So I'll put here minus 1. Okay? So let's look forward and now continue with the multiplication. Negative 1 times 1 gives us negative 1. Negative 1 times 1 gives us negative 1. And negative 1 times 1 gives us negative 1. So all of these give us negative 1. So what's going to happen here? We end up with negative 1 times negative 1 minus 1 minus 1. That gives us negative 3. And that solves this issue. So we found our last term, which is negative 3. Now we're going to write this out here. We'll draw this out in red as well. So these little blocks are going to be negative 1 and then negative 1 and negative 1. Okay. And let's take a look. So minus 1, minus 1, minus 1. Great. So all of my factored terms are there. We have x squared and x squared. It gives you 2x squared. Check. We have x, 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 x. That's 6x minus x gives us 5x. Check. And then we have the minus 1, minus 1, minus 1 gives us minus 3. Check. So all of this works for us. And so we got all those checks there. That's fine. Now we need to write our factors. We're going to put this back in white. And our factors are basically the x plus 3 and our second factor is going to be x plus x is 2x, and then there's a minus 1. Okay, I think that is out of the page here, so I'll just write that, let me just write this here, equals x plus 3, and then we have 2x minus 1. Yeah, that works. Okay, so now if you notice, we've got our factors using algebraic tiles, and we've dealt with a complex quadratic expression. It's not a simple trinomial, it's a more complex. We started again from the basics. We started from the basics, and we have a series of in our expression we have 3 terms with different exponents. So we're dealing with different variables. So again, highest degree is 2, and we worked around taking the simplified expression, starting with the building blocks and working our way backwards to find the proper factors. It does take a lot more time than the rubric of product-sum rule or crisscross method or others, but it's good to visualize to see how these algebraic tiles, or how the physical sort of diagram representation of factoring works. And we can use this in other applications in terms of area and volume, and looking at it from a 3-dimensional perspective or two-dimensional perspective as well, and understand the factoring, what it's actually doing and what it means. We're actually breaking it apart and seeing the meaning behind it. So hopefully this video helped you guys out. Like it if this helped you. If you have any questions or any problems that you're not sure about, you can't really get the answer, you can always send me a quick message. You can also visit my website, dawoodacademy.com. I do offer tutoring sessions for math and science. I have a Bachelor of Science degree, Bachelor of Science degree in chemistry and biology from Ryerson University. I've worked in laboratories for many years as well. I've done tutoring for the past 5 years, and as my full-time occupation. You really understand science and work through problems with critical thinking, as opposed to just looking for answers or getting solutions. I really focus on my students to build the building blocks, and I really put a lot of passion and effort for my students to understand how to work through problems, even if they had really little to no background. So even if they had little to no background in the certain area that they're working with, that they can take those building blocks that they've learned throughout these years and establish them and use them to come to proper, legitimate solutions in their questions that they're working with.